Welcome back. We'll look at a few more Lia details now, including the use of a namespace file for simpler program organization. But first, I wanted to add a way to cancel a running task. So I've added a new button for this purpose. This button will invoke a new method called cancelRead in the main app. This method simply calls the abort method on a new field called currentTask if the field is not null. That field is set when our demo task begins and will be set to null when the demo task completes. The invocation of an object method after confirming that the object is not null is another common pattern. So Lia provides the thin arrow operator as a shortcut for this pattern. If the target object is null, then no invocation is done, and an appropriate null or zero value is returned depending on the method type. This operator can be chained in the same way as the dot operator. We'll run the application now. But we will see that although the cancel button is responsive, the demo task does not seem to stop in response to it. This is because the abort method only makes a request to the task for it to stop. The task itself must monitor its progress object to determine if an abort has been requested and can respond accordingly. If it never checks, it will never abort. So we'll call the checkShouldStop method in the task's progress object. This method will throw an aborted exception object, which is the standard way to indicate that the process is stopped due to an external abort request. So we will call that method after the initial sleep and in every iteration of the counting loop. So if we save the new code, we will see that the cancel button now stops the demo task from operating. However, the progress bar does not make a distinction between a task that stopped because it succeeded from one that was aborted. So we will fix that by going back into progress bar. We will change the method where the progress bar updates its state from the handle and now explicitly check for an abort or fail condition. So in the case that the handle is complete, we check if it was aborted or if it failed for some other reason and report these two conditions. Now, when we cancel the operation, it will display the fact that it was aborted. So let's modify our demo task to do some real-world I/O. Specifically, we'll do a simple web request to get some static text data. To do that, we will get an instance of the Lia net object, which can provide us with an object to create a new HTTP request. We'll provide it with the URL we want to access, and if we don't provide any post data, it will default to performing a GET request. We will see that the compiler marks two method calls as errors. This is because they both throw checked exceptions, while our method does not declare that it throws any checked exceptions. If we don't want our method to declare any checked exceptions, we can simply put the expression not throws at the start of the method, in the same location where we would normally declare our checked exceptions. This tells the method to catch any checked exceptions and then rethrow them as unchecked runtime exceptions instead. The last two calls we made makes a streaming text connection to the remote host and then reads all the data as a single string. We will then use a string list object to split the text into individual lines in a string array. We'll then display those lines in our line display control. So when we press the button, we will see that the app fetches the text and displays it in the line display, which we can scroll up or down by using the mouse or by touch. Let's look at creating a small library of utilities using a namespace. A namespace allows you to group together methods, classes, and interfaces into a single file in a less formal way than you normally would, and allows code that uses the library to do so by using a simple import. You can start by creating a normal class, which we will call NetTools. But then you will change the class declaration to say namespace instead of class. Unlike with normal classes, any class or class member declared in a namespace will default to being public, and classes will default to being static. We'll start by declaring a simple class called HTTPResult that we'll use as a return value from a GET or POST operation. It will contain the response code that the server gave as well as the body of the response if present. Then we'll write a simple GET method that does an HTTP request as we did before and returns the result of the GET as an HTTP result object. We'll also use the not throws declaration so that the GET method does not throw any checked exceptions. So we'll end up with a method call that is much easier to use than if we had to configure the HTTP request each time we wanted to do a GET. So let's use the library in our main app. To do this, we add an import at the top of our code as before, but now we can assign a short name, an alias, to the library. We'll call it net. Then we will change our task to use the GET method in the library to fetch the data. Everything else will stay the same. When we run the app, we'll see that it works as it did before. Let's modify the GET method to allow for retrieving binary data as well. We'll add a field to contain a byte array in the case where binary data is requested. And then we will add an optional Boolean parameter that can be set to true to indicate that binary data is required. So by using the optional parameter, we could request binary data from the GET method. But we'll continue to stick with text for our demo. So let's modify our library to add an HTTP post method. This post method will allow us to send either text or binary data as the post body data. And as with GET, we'll also take an optional parameter indicating whether we want binary data or not. Since the HTTP request operates the same once it has been set up, I'll use a common private method so that I don't repeat my code. So let's go to the main app and use this new method. To test the post method, I'll send a request to a public site that allows you to test your HTTP calls and will send back to you any post data that you send to it. And I will set it up so that the task will alternate between doing a GET and doing a POST so that we can see them both working. So we can run it again and see both the POST and the GET in action. There's our response from the POST. And the one from the GET. And the POST again. Before we end, let's do builds for JavaScript and Windows. We can see that it works as expected in a browser. So let's do a Windows build too. And we can see that this build works the same. Thank you for watching this video, and please look out for more information on Lia in the near future.